Mercury is the smallest planet, or often called the runt of our solar system. Basically, we're going to go over the history of Mercury and how it ended up the way it did. We're going to also answer some questions about why the core is so big. Where was Mercury at its time before a collision course that happened? So we're going to go far back, about 4.5 billion years ago, where we understand some of these questions that we're going to be asking. So my name is Chris. Welcome to the universe. Subscribe to the channel if you guys are brand new. Let's get started. So Mercury's rotation period is about 59 days, and its revolution period orbits around the sun is every 88 days. And it's the fastest planet of our solar system. So we're going to talk about the formation of Mercury to answer some of our questions and theorize what could possibly happen to Mercury 4.5 billion years ago. Well, let's go start from the outside in. On the outside, Mercury is this pummeled rock that's just heavily cratered. It has tectonic activity where you have all three types of tectonic activities. You would have the convergence, you have divergence, and also you have transform plate boundaries. Because Mercury is actually shrinking in size. And this is due to the massive core that's inside Mercury that takes up 85% of its entire volume. But here's where we're going to be theorizing this question here. Why on earth does Mercury have a giant inner core that takes up most of its volume? So 4.5 billion years ago, Proto-Mercury was formed along with its siblings, Venus, Earth, and Mars at one point. They were formed out of these dust grains of our solar system, and all these rocks and dust coalesced. But did you know that those four main rocky planets actually formed out of that previous chaos? Now, 4.5 billion years ago, it was a very chaotic world. Basically, you had the early proto rocky planets basically just smashing in each other, ejecting off, and get flung into the sun or flung out somewhere, wherever. Basically, that set the stage to the formation of the four rocky planets that we know of. But as we run the clock a little bit more, so about 4.5 billion years ago, our four main rocky planets had a devastating impact by a collision course. Mercury had a collision course that changed its surface. Venus had a collision course that altered its rotation. Earth had obviously the collision course with Theia that eventually formed our moon. Mars had a collision course, but now we're going to be focused on the collision that changed Mercury's size. So Mercury is often called the runt of our solar system because of that impact. But let's also theorize. Where was early Mercury at its time? So let's theorize it. Mercury was further away from the sun, right in between Venus and Earth's orbit, right? Okay, so some altering, and you have the influence, the resonance between Venus and Earth. But also, surrounding the four inner planets, you also had the early inner planets that were also surrounding. So you had a little bit more, it's about 10, maybe 20, maybe 100 other little proto rocky planets that were a little small. But this one was a giant impactor, and it was about the size of Ceres, for example. Okay? And over time, the course of these resonances changed as each protoplanet was gaining mass and they're setting up their resonances that were pulling in bigger objects. Okay? So at that one point, Mercury was a molten ball of just rock that was probably about the size of Mars at the time. And it kept attracting bigger and bigger objects until it altered an orbit of this Ceres sized object, okay? Or it was came from somewhere else. And it slammed into Mercury at a very high rate of speed. But also, it altered young Mercury's orbit too. So it altered the orbit as well. So enough force of that blow that Mercury had suffered actually sped up Mercury and started forcing it towards the sun. Eventually, the sun's gravity pulled on Mercury closer and slowed it down to around its present distance from the sun, 36 million miles. Okay? So, again, a high impact speed that blew off billions of tons of rock from its crust and mantle, but also it was a direct angle, just enough to pretty much blow off the outer parts, the inner part intact, pretty much. So that impact speed, probably about faster than Thea's collision with Earth. So let's say about 40,000 miles per hour, but it struck it at a right angle so it doesn't disturb the outer parts. So all of those chunks pretty much flung off. Lighter materials flung around the protoplanets and probably towards the sun were leaving behind these heavier chunks that rained down on Mercury and causing these high impact craters early on. So you see the oldest impact craters on Mercury, and we always seen from the messenger probes that orbit around Mercury at one point. And so surrounding that entire geography is basically all these high impact craters just pummeled just around the entire surface itself. And like I said, these are very old craters that existed 4.5 billion years ago. Because all these heavier materials pummeled and recoalesced and built up Mercury enough, but those heavy materials sank back down. And guess what? It formed that giant core that we've been talking about that makes up 85% of the entire volume. Because Mercury was molten at the time, so it kind of had enough time to pretty much draw in these heavy materials and sink. So that's why Mercury is left as a very dense iron and nickel ball. But also, let's talk about the rest of the geography. So also you see fissure lines, you see these convergence, these fault lines, these tectonic activity, and why Mercury is also shrinking is because this massive inner core is basically causing uneven convection, also influenced just by how close the distance away from the sun it is, also influences its activity as well. Because when you heat up a metal, it expands, obviously, but also you have the influence of gravity because it's pulling on an object and pulling it in. So it almost causes almost a tidal lock to the sun because it's close proximity, right? So pretty much like that whole geography changes because of uneven strains and forces that cause on Mercury's surface as it creates these tectonic activities. So yeah, that's the whole story of Mercury for right now, just by understanding where Mercury was when it's furthest away, how big it was early on, what happened during the collision course, and why Mercury is the closest planet to the sun. So thank you guys so much for watching. I'll see you guys in the next video. Make sure to like and subscribe to the channel if you guys are brand new for more space content. And as always, keep exploring.